Formula mass means adding together all the atomic masses. Fe2 means 2 Fe's, 2 ions, and O3 means 3 oxygens. So 2 times the iron, 2 times 56, added to 3 times the oxygen 16 should give you 160. If they ask for the percentage by mass of iron, they're asking how much of the Fe2O3 is iron. And so it's 2 times 56 is iron out of 160. That should give you 70%. 2 times 56 is 112 divided by 160 times by 100, because it is a percentage, gives you 70%. Think about if you're actually doing this chemical reaction, the first most obvious sign are these, the bubbles of gas. You should also see the magnesium starting to dissolve or disappear. This is a 6-mark question investigating how the rate of this reaction, the magnesium and hydrochloric acid, changes when the concentration of the hydrochloric acid is changed. Your first couple of marks are actually just for describing what you need to do in terms of the reaction. First mark, this reaction, the magnesium needs to be added to the hydrochloric acid. Second mark, the concentration of the hydrochloric acid needs to be changed. You actually get a mark for saying that. But then you also need to talk about what you would do to make it a fair test. So what things are you going to keep the same so that they don't affect the results? One thing you would need to keep the same is the amount of magnesium, the mass of magnesium, and you get a mark for saying that. If you also say the volume of the hydrochloric acid, the amount of it that you use needs to stay the same, there's another mark for that as well. So we've talked about the independent variable, the thing you're going to change, the concentration, and we've talked about the control variables. The other measurement you'd need to make is actually your dependent variable, the result. And so here what you'd be expected to measure for a mark is the volume of gas, or the amount of bubbles that is made in this chemical reaction. The final mark is probably going to be given for using good English and organising the information clearly. So if you've written things in a logical order, that should get you the 6th mark. In this question we're talking about electrolysis of sodium chloride. So if it's electrolysis, straight away we want to be thinking about ions. If we have the positive electrode, remember the positive one is known as your anode, so don't panic. Positive is anode, negative is your cathode. And so if your anode is positive, that must mean the chlorine is negative, that's your negative ion. And if your cathode is negative, that must mean that the hydrogen is positive. So the hydrogen ions, which are positive, move to the negative electrode because opposites attract. If you weren't sure what the charge was on your hydrogen ion, just look it up on your ions table. This question here, just be careful, it's asking you how a hydrogen ion, so a H plus ion, is going to turn into a hydrogen atom, a H. To get rid of that plus, it's going to have to gain electrons. So electrons are going to be added to the ion. It's going to gain 1 electron to turn it into the neutral atom. This one here, it says use dots and crosses to show electrons. So if we say that the dots are going to be for the hydrogen electrons, so we've got a dot here, a dot here, and a dot here. So 3 dots, 1 for each hydrogen electron. And then your nitrogen is actually in group 5, so that means it has 5 electrons in its outer shell. So 1 is in a pair here, 2nd is in a pair here, 3rd is in a pair here. That's your 3 bonds between nitrogen and hydrogen. But that's only 3 of the 5. So the 4th and the 5th one are actually going to be in a lone pair as well. Make sure you've included the pairs which make up the bonds, and they're drawn in the overlap here. And don't forget this lone pair as well, so the 2 electrons that make it up to 5 electrons in the outer shell of nitrogen. This one here, if we're looking at what makes the waste alkaline, remember that alkali is caused by the hydroxide. If you were looking at what makes something acidic, that is your hydrogen ions that make it acidic, but they're asking alkaline, and so that's your hydroxide ion. If you want the ionic equation for neutralization, then you're going to take your positive acidic hydrogen ion and your negative alkali hydroxide ion, OH-, to make H2O neutralised. You've made water. So you've got your H plus from the acid reacting with the OH- from your alkali. The acid and the alkali neutralise and form your neutral water, your H2O, and that is the ionic equation for neutralisation. This question here is actually asking you to draw the chloride ion, so it's asking you to draw the Cl- ion. If this is our chlorine, notice that you've got an electron here which makes up the 7 electrons in the outer shell of the chlorine atom. If we want to create a full outer shell, we're going to add an extra electron to the outer shell here, and so what your final diagram should look like is you should have the crosses all the way around with 2 in the first shell, 8 in the next shell, and 8 in the final shell. This electron here is negative, so that's why it makes it Cl-, so that's a negative electron, and that's what gives you the negative charge on your chlorine minus ion. This question here is the opposite of what we looked at with the hydrogen ion. This time it's an atom of calcium turning into a calcium ion that has a 2+ charge. If it's becoming more positive, that must mean that it's lost electrons, so you have electrons left over, and because it's a 2+ charge, it must have lost 2 electrons. This question here, where it's asking you to balance the equations, be really careful. You can't just change the chemicals. You can't just write in something to make that chemical balance the equation. You're only allowed to put large numbers in front of each one. If you look here, I've got 10 oxygens on this side and only 2. So to make it balance, I need 5 O2s. This example here, I've got 4 lots of 4 oxygen on this side, so that's 16 oxygens altogether. I've already got 10 here, so to make it up to 16 and make it balance, I'd add 6 H2Os. You can double check that that makes sense in terms of the hydrogens as well. So I've got 4 lots of 3 hydrogen here, that's 12 hydrogens, and here I've got 6 lots of 2 hydrogens, so that's 12 hydrogens as well. So here you've got your core of the Earth, and the core of the Earth is really, really hot. So actually there's no way that we could travel to the centre to prove this theory. So the reason why scientists can't prove it, it's too hot, you can't get to the centre of the Earth. This question is asking you to explain why the Earth's tectonic plates moves. Be careful, here it's 3 marks, we want 3 separate points in our explanation. If you think back to the diagram, you had the core, and then you have the mantle around it, and then you have the crust around that. What goes on in the mantle is that actually, and it mentioned this earlier in the question, you have radioactive decay, and that radioactive decay means that a lot of heat is given out to the mantle. So if that heat is given out in the mantle, that heat causes the mantle to move, and we actually say that that's a convection current. If the heat caused by the radioactive decay is causing the mantle to move to give you a convection current, that can then move the tectonic plates. If you're asked to calculate the simplest empirical formula of this substance, it's asking you to give a chemical formula, and it wants you to tell them how many iron atoms and how many oxygen atoms there are. Make sure you have your numbers the right way around. If it's 70% of iron, then you do 70 divided by the atomic mass, 70 divided by 56. And if it's 30% of oxygen, you do 30 divided by the atomic mass of oxygen, which is 16. That should give you, so for your iron, 70 divided by 56 gives you 1.25. And then 30% of oxygen divided by the 16 for oxygen gives you 1.875. You can't just round these. What you have to do is you have to try and find the simplest whole number ratio, and the easiest way of doing that is by dividing by the smallest number. So 1.25 divided by the smallest number, 1.25, is just equal to 1. And then if you do 1.875 divided by the smallest number, 1.25, then that is going to be equal to 1.5. And that's still not a whole number ratio, but it's a lot easier to think about 1 to 1.5 instead of 1.25 to 1.875. And a ratio of 1 to 1.5 is the same as a ratio of 2 to 3. And so that means that for every 2 of your iron atoms, you are going to have 3 of your oxygen atoms. And so your empirical formula is Fe2O3. This question is about the limestone cycle, but the type of reaction that happens when any metal carbonate is heated is known as thermal decomposition. Think about what atoms you've got. If you've got calcium carbonate, that is going to thermally decompose. It's going to break down into calcium oxide and carbon dioxide. 1 mark for saying it's thermal decomposition, thermal heat, decomposition, breaking down. 1 mark saying calcium oxide, 1 mark saying carbon dioxide. In this experiment here, they're hoping that you're actually going to spot that there is an anomalous result. That anomalous result of 1 shouldn't be included in your calculation of your mean. So your mean should actually just be 1.8 plus 1.9 plus 1.7 divided by the 1, 2, 3 values that you've used to calculate your average. If you add that up and divide it by 3, then your final answer should be 1.8 grams as an average, ignoring the anomalous result in experiment 2. If you are using plants to extract it, that's plants with a P, and that is phytomining with a P as well. Reasons why you might not extract copper by smelting. If you use phytomining, that's where you only have a very small amount of copper, and so it wouldn't be worthwhile trying to extract it. It'd be too expensive to extract it. In this question here, first thing I'd do is look and see actually on the left hand side I've got some copper, but on the right hand side I haven't got any, so straight away I know that this has to be copper that I'm producing as a product. Then in terms of balancing it, over this side here I've got 2 oxygens. I can't just write a little 2 next to the oxygen, I can only put a number in front of it, so I could make 2 CuO, and then go back to the right hand side, and actually now I've only got 1 copper. I can't write a little 2 next to it, but I can write a large 2 in front of it. And if I check now, on the left hand side I've got 2 coppers, 2 oxygens and 1 carbon. On the right hand side I've got 2 coppers, 2 oxygens and 1 carbon. In this question, make sure you give 2 reasons why scrap iron is used to displace copper. First clue is that it's scrap iron, that's cheap, so that's one reason. And then it says use the chemistry data sheet to help you answer this question. If you look on the chemistry data sheet and using this hint here that it's a displacement reaction, you can actually see that iron is more reactive than copper, so it will displace copper, and that's your second reason. Iron is more reactive than copper. In this question here, describe what happens to the copper ions during electrolysis. So these copper ions in solution, first thing that's going to happen, and it's shown by this arrow here, is those positive ions will move to the negative electrode. Once they get there, that negative electrode has loads of negative electrons, and that means that the copper 2 plus can gain 2 electrons, so copper 2 plus will gain 2 electrons, and it will turn into a copper atom, and so you'll get copper all around that negative electrode. This question here, you have got a reaction with oxygen, so that should be making you think that this is a combustion reaction, and in combustion you always get H2O, water, and CO2, carbon dioxide. This question here, CaCO3, making CO2, is very similar to the question that you had earlier in this paper. So CaCO3, if it's made CO2, the atoms that are left over are Ca and O, calcium oxide. In this question here, check that you're going to earn your 2 marks. You've got to say about the 2 different sections of the graph. First of all, you've got a decrease, but it's the fact that this decrease has slowed down. It's a less rapid decrease from about 3,000 million years ago. So break the graph up into two different sections. You've got quite a rapid decrease in the first section, and then you've got a slower decrease, a more gradual decrease in the second section. Be really careful here. It says give 2 reasons why the percentage of carbon dioxide has changed, and the graph is showing that that change is a decrease. Make sure you're giving reasons for why it would have decreased. Your main reasons are photosynthesis will mean that plants are absorbing carbon dioxide, it's decreasing. You could also say that carbon dioxide is absorbed by the oceans, or you could also say that carbon dioxide is locked up in carbonate rocks. In this question, use the diagrams to help you. The first mark is for saying that graphite is in layers. The second mark is for saying those layers can slide over each other. Third mark is for talking about diamond and the fact that it's got 1, 2, 3, 4 covalent bonds around every carbon atom. These dots are your carbon atoms. And the fourth mark is for saying the fact it's got those 4 strong covalent bonds around it makes this a very rigid structure, makes it a very strong structure. This one's about conduction, and again, you want to refer back to the two different diagrams. So in your graphite, you have got 3 bonds around every carbon. So in graphite, we've got 1, 2, 3 bonds around every carbon. Carbon's in group 4, it's got 4 electrons, so if there's only 3 bonds, there is 1 free electron in graphite. And this free electron can move through the structure and carry the charge. If you don't talk about carrying the charge, then you won't get the next mark. 1 mark for talking about there being a free electron in graphite. 1 mark for talking about that free electron carrying the charge through the structure, conducting the electricity. But if you look at your diamond, all 4 electrons are used in those 4 bonds around each carbon, so there are no free electrons to carry the charge and conduct the electricity. That's your third mark, is saying that there are no free electrons to carry the charge.